Okay, we're going to finish this lesson off by doing a couple of application problems. The first one says, how high is a flagpole that casts a 56-foot shadow at the same time that a 6-foot man cast a 5-foot shadow? Hint, the angles formed by the sun's rays are congruent because the shadows are measured at the same time. And so if we consider, how shadows are created, the sun, and you can draw this on one side or the other, so your sun might be on the opposite side, but we have the sun, and the sun will hit the flagpole. So say up here we have a flagpole, and when it hits the flagpole, it creates a shadow that is 56 feet. At the same time of day, the sun is going to hit a man, and it's also going to create a shadow. So this man is 6 feet tall, and his shadow is 5 feet long. So the question that it's asking is, how high is the flagpole? How tall is this flagpole? So that's going to be our unknown. And it also explains that the angle created from the sun's rays are congruent because the shadows are measured at the same time. And so if we consider these triangles here, we'll pretend that I drew that correctly. Let me kind of clean that up just a tiny bit. So what will happen here is that this angle here is going to be congruent to this angle here because the angle created by the sun, they're going to be the same because they're measured at the same time. This is also going to be considered a right angle here in this problem, and also this angle will end up being congruent to this angle because the shadows, are created by the sun at the same time. And so these are similar triangles by angle. And because of that, we can use the fact that the sides are proportional in similar triangles to find the unknown measurement, which is, in this problem, the height of the triangle. There are multiple ways to set up the proportion, and I'll show you a couple, but x corresponds to 6. Those are both the height. And 56 corresponds to 5. Those are both the shadows. But, some people set the proportions up differently. You could do, 6 over x equals 5 over 56. And that would give you the exact same thing. In that problem, I went smaller to bigger instead of bigger to smaller. You can also do x over 56 equals 6 over 5, or even 56 over x equals 5 over 6. You just have to make sure that the way you choose to set up your first ratio, you're consistent with that on your second ratio. And so the way that we solve these ratios is we're going to cross multiply. And notice, in either one of these that I did, you end up multiplying the same thing, 5 and x and 56 and 6. So 5 times x is 5x. 56 times 6 is 336. We then go through and divide by 5. And, you can definitely use a calculator if you want. If I take 336 and divide it by 5, 5 goes into 33 6 times to give me 30. We subtract here, we get 3, we bring down a 6. It's going to now go in 7 times to give me 35 with a remainder of 1. And we are in feet. So this here would be 67 and 1/5 of a foot. 67 and 1/5 of a foot would be the height of that. Now, I would also accept that, in a decimal form. That's fine. If you did it in your calculator, let's say, you take 336 and you divide that by 5, you're going to get 67 and 2/10, which is the exact same thing as 67 and 1/5 of a foot. All right, let's do one more to finish off this lesson. So this one says, Monica is standing 75 feet from the base of a tree. The shadow from the top of Monica's head coincides with the shadow from the top of the tree. if Monica is 5 feet 9 inches tall and her shadow is 7 feet tall, how tall is the tree? And this is one, sometimes on these I have to read these a few times to make sure I truly understand how it's working. Again, we're working with a shadow, and so shadows are created by the sun. So Monica's standing 75 feet from the base of a tree. The shadow from the top of Monica's head coincides with the shadow from the top of the tree. If Monica is 5 feet 9 inches tall and her shadow is 7 feet tall, how tall is the tree? So, and like I said, we don't all have to draw these the same way, because you might do it opposite. Like you might put your tree on this side and your sun on this side, and that's okay. But we have the tree, and then over here we're going to have Monica. We'll give her a ponytail, okay? And then we have an extended mount. Now the key here, and what you really need to pay attention to, is that her shadow coincides with the shadow from the top of the tree. So she is 75 feet from the base of the tree. She is 5 feet 9 inches. Okay, so we don't want feet and inches in the same problem. So she's 5 feet and 9 inches out of 12 inches. That makes a foot. And so if you think about that, that's 5 inches, or excuse me, 5 feet and 3/4 of a foot, because it's 9 inches out of 12. That reduces to 3/4. So I'm going to change this to 5.75 in a decimal version. It's not 5.9 because it takes 12 inches to make a foot. And so 5 feet 9 inches is 9 inches out of 12, which reduces to 3/4, which we know is 5 75/100. Her shadow is 7 feet. And when we think about coincides, what that means is it coincides with the shadow from the top of the tree. So what happens is we have these two triangles that are created, and I'm going to do my best. I'm going to need to erase just a little bit again because I didn't draw that quite right. But I'm going to erase just a little bit off the end here and draw this in. So what the coincide means is that her triangle is inside this larger triangle. And my pen just went a bit crazy. So let me erase this and try it again. So it's not. Give me just a second to get this fixed. Okay, so I think I kind of have this drawn better to where we can see. So the problem told us that Monica here is 75 feet from the base of the tree. The shadow from the top of her head coincides, which means it's within the shadow from the top of the tree. If Monica is 5 feet 9 inches, which we converted to 5 75/100 of a foot, and her shadow is 7 feet, how tall is the tree, which is why I put the unknown variable x here by the height of the tree. Now, some people, again, need to separate these triangles, and these are not going to be drawn to scale, but I'm going to go ahead and draw them separately so we don't know the height of the tree. But if you think about the base of this triangle to the end of her shadow, and including the height of the tree, that's going to be 82, because that's what 75 plus 7 is. She's 75 feet from the base of the tree, but it's still 7 more feet to the end of her shadow. Now the other triangle, where she is with, that coincides, this is 5 75/100. That's how tall she is, and her shadow is 7 feet. And so some people just do well with separating those before setting up the proportion, but that's going to be, completely up to you. Then you can set up the proportion. X corresponds to 5 75/100. 82 corresponds to 7. And so what I did is height over height, and base over base. And like I said, you could go the other way. You could do height over height the reverse way, base over base the reverse way. You could even do x over 82. So some people like to do x over 82 equals 5 and 75 hundredths over 7. That's all the same. There's 4 different ways you could write the proportion here. Now we're going to go ahead and cross multiply. So we'll do 7 times x is 7x. And then you can use a calculator. You can take 82 times 5 and 75 hundredths. That's going to give you 471 and 5/10. And then when you get there, you're going to go ahead and divide through by 7. So we'll divide both sides by 7. And then when we finish that, when we go through and divide by 7, we're going to round this to the nearest hundredth. And so the height of the tree is approximately rounded to the nearest hundredth, 67 and 36 hundredths. And you could go through and work that without a calculator and leave that in fraction form, and that would be great as well. And let's not forget our units here, and I apologize for not doing that. It's in feet, and then let me go back and check the other one. Yes, we did include our units on that last one as well.